Hello student, today our chapter is chapter 6 triangle. In this, first we will go with the introduction. In introduction, we will study about congruent and similar figure, right? What are congruent figure? You are familiar with the congruency and congruent figure. Congruent figures. Actually, congruent figures are those figures having equal shape and equal size. For example, you can take two circles of equal radius and two squares of equal side, and many more examples you can take here. Now I am discussing about similar figure. Similar figure are those figures having equal shape but need not to be equal size, right? So here we can say the two similar figures like two circles of different radius and two squares of different sides, and many more examples we can take here of a similar figure. And this is, you can easily see the difference between congruent figure and similar figure. In this chapter we will study about similar triangle. For similar triangle there is a different criteria. So the criteria are first one is angle criteria. In this criteria, one triangle is similar to other triangle if its corresponding angles are equal to each other. Here, if A is equal to D and B equal to E and C equal to F, then we can say triangle ABC is similar to triangle DEF by the criteria of angle. Now the second one is side angle criteria. In this, if in a triangle like ABC and DEF, the ratio of any two corresponding sides and the angle between them are equal. Like if AB upon DE equals to AC upon DEF. and one angle between them is equal, then you can say triangle ABC is similar to triangle DEF, right? Now the third one is if a triangle ABC and triangle DEF, if the corresponding sides are proportionally equal, like then we can say like if this is side criteria, and this if AB upon DE equals to AC upon DF equals to BC upon EF, then we can say triangle ABC is similar to triangle DEF. These are the three criteria for similarity of triangle. Now we will come to the theorem regarding this chapter, the first theorem of this chapter, that is PPT theorem, right? Like theorem 6.1 PPT theorem, that is basic proportional theorem, right? First we will write the statement. What is the statement of this theorem? If a line drawn parallel to one side of a triangle, and intersect the other two sides in distinct point, then the other two sides are divided in the same ratio, right? This is the statement of our PPT theorem. So before proving this theorem, I am drawing the figure in which we have one triangle is given and one line. I am assuming DE, which is parallel to BC, right? So here I am doing the solution of this theorem. So here first I am writing the given part, that is in triangle ABC we have DE parallel to BC, right? To prove we have to prove AD upon DB equals to AE upon EC, right? Now in this step we will do the construction. For construction we will draw the two perpendicular, one from D and one from E. We will put their naming M and N and join B to E and D to C. So here I am writing draw DN perpendicular to AC and EN perpendicular to AB and join B to E and C to D. Now we will come to the proof of this theorem. For proving the theorem, we know what we know. The area of triangle ADE. We are familiar with the formula of area of triangle, that is half base into height. Here I am taking half. Base from this side is AD and height is EN. Right? Now again, I am taking the area of triangle and area of triangle BDE. Right? This is actually a obtuse triangle. For obtuse triangle, the perpendicular on outside of a triangle. So base is DB and the height is EN. I am putting them equation 1 and 2. So now we will divide equation 1 and equation 2. Now on dividing equation 1 and equation 2, we will get area of triangle ADE upon area of triangle BDE. So we will get half into AD into EN and on denominator half into DB into EN. Here we will cancel out the same term. We will get AD upon DB. We will write this equation 3. Similarly, we will get from this side area of triangle ADE and from this side I am taking ADE and triangle of area triangle DEC. So from this side the base will be AE and height will be DM and half base is EC and height again it is an obtuse triangle, so height is DM. Now we will cancel out the same term, like term. So we will get AE upon EC. This is equation 4. Now we know what we know. We have done that in 9th class. The triangle on same base and between same triangle are equal in area. Triangle on same base and between same parallel are equal in areas. So here we can see these two triangles having same base D and same parallel D parallel BC. So we can write area of triangle BDE equals to area of triangle DEC, or we can write it like a 1 upon area of triangle BDE equals to 1 upon area of triangle DEC, or we can multiply by ADE to the both side. Area of triangle ADE upon area of triangle BDE equals to area of triangle ADE upon area of triangle BDE. This we can put the equation 5, right? Now from equation 3rd, 4th and 5th, from equation 3rd, 4th and 5th, we can see the ratio of the area of triangles are equal, then the ratio of side will also be equal. So AD upon DB equals to AE upon EC. This is the proof of our BPT theorem, right? So I am taking one question to clarify this proof, right? So I am taking one question which will clear your doubt. Like if we have a triangle, like in triangle ABC, if D parallel to BC and AD is 1.5 and BDB is 3 and A is 1 centimeter, then find the value of EC. So here we will do the solution, like since DE parallel to BC, so by BPT we can write AD upon DB equals to AE upon EC. So we can put the value here. AD is 1.5, DB is 3 and A is 1 and EC we need to find. Now we can solve this. We can remove the decimal and write the 0 here. Now 15 1 ja, 15 2 ja. So we will cross multiply it. Now the EC is 2 centimeter. So the value of EC will be 2 centimeter. So this is the question regarding to this theorem. Many more questions you can see in your exercise. Can do practice. So now we will come to the next theorem, that is converse of this theorem. That is converse of the midpoint theorem, right? So what is the converse of midpoint theorem? Now converse of BPT, right? So first we will write the statement. In the statement, it is just opposite to the BPT theorem. In this, if a line divides any two sides of a triangle in same ratio, then the line must be parallel to the third side. Parallel to the third side. Right? Now we will do the proof of this theorem. For that, I am taking one triangle ABC. Here I am taking the line D parallel, which is I am writing what is given if a line divides any two sides of a triangle in same ratio, in this triangle, in triangle ABC, right, we have DAD upon DB equals to AE upon EC, right? To prove, here we need to prove DE parallel to BC, right? Now I am taking proof. In proof, I am just assuming a line. If D is not parallel, I am taking DF is a line which is parallel to. In proof, if D is not parallel to BC, then assume DF parallel to BC. So now, since DF parallel to BC, so by PPT we can write what we can write. The ratio will become equal AD upon DB equals to AF upon FC. This we will put equation 1, and we have, you can write, and AD upon DB equals to AE upon EC. This is given, right? Now by equation first and second, equation first and second, we can see the left hand sides are equal, then right hand side will also be equal. AF upon FC equals to AE upon EC, right? Now here what we can do, we will add 1 to the both side. So we will take LCM. It will be AF plus FC, and here AE plus EC. So from figure you can see it is AF plus FC will become AC upon FC, and AE plus EC will also become AC upon EC. Now AC will cancel out. Now we can write EC equal to FC. So you can see EC will become F equal to FC. It can only be possible. It can only be possible when F and E are coincident point, right? It can only be possible when F and E are coincident points. So that is DE parallel to BC. So this is the proof of the converse of BPT theorem. Now I am taking one question to clarify this theorem, and the question which are based on this theorem, right? So here I am taking one question like we have one figure, triangle PQR, right? And this is a line EF, and this is a point of D on PO. So here in figure we have DE parallel to OQ, DE parallel to OQ, and DF parallel to OR. So show that EF parallel to QR, right? So in this solution, first we will write, since DE, first you will write in triangle POQ, since DE parallel to OQ. So by PPT, you can write PD upon DO equals to PE upon EQ. This is equation 1. Now in triangle POR, you can see DF parallel to OR, DF parallel to OR. Again, by BPT, we can say PF upon FR equals to PD upon DO. This is equation 2. Now, by equation first and second, we can see PD upon DO are equal. So that's why PE upon EQ equals to PF upon FR. So here you can see PF upon FR equals to PE upon EQ. So by converse of BPT, what you can say, if the ratios are equal, then line will be parallel. Then EF parallel to QR has to. So this is the question which is based on converse of BPT theorem, right? Now we will come to the next type of theorem. The third theorem, similar triangle theorem, right? What is similar triangle theorem? Now, theorem is similar triangle theorem, right? First, we will write the statement of this theorem. What is the statement of this theorem? The ratio of area of two similar triangle is equal to the square of the ratio of their corresponding sides, right? So this is the statement of similar triangle theorem. So now we will do the solution. For that I am drawing two triangles here. The triangle ABC and triangle PQR, right? So first I am writing the given part here. triangle ABC is similar to triangle PQR, which is given. To prove area of triangle ABC upon area of triangle PQR equals to the ratio of the square of corresponding side, which can be AB square upon PQ square equals to BC square upon QR square equals to AC square upon PR square. Now we will do the construction. In construction, we will draw two perpendicular here. AM perpendicular to BC. Draw AM perpendicular to BC and PN perpendicular to QR. Right? Now we will come to the proof of this theorem. Here, since triangle ABC is similar to triangle PQR, which is given, so we can write ratio of the side AB upon PQ equals to BC upon QR equals to AC upon PR, and the angles are also equal, and angle A equals to angle P, angle B equals to angle Q, and angle C equals to angle R. We will assume this like equation 1. Now we will go further. Now here we will take two triangles of an area. Now in triangle we will do the similarity in these two triangles, in triangle ABM and triangle PQN. Here we can see angle B equals to angle Q by equation 1, and angle AMB equals to angle PNQ. If any two triangles are equal, then we can say triangles are similar. So triangle ABN similar to triangle PQN by angle criteria. Right? This is also criteria. If any two angles are equal, then third angle will clearly equal. So we can prove similarity of two triangles by equating any two angles. Right? Now it implies AB upon PQ equals to AM upon PN. This is equation 2. Now by equation 1 and equation 2, we can write AB upon PQ equals to BC upon QR equals to AC upon PR equals to AM upon PN. Right? We can write it like this. Now we will do the ratio of area of triangle ABC or area of triangle PQR. then the triangle area is half base into height, that is BC into AN, and in denominator half base is QR and height is PN. Now we will cancel out half by half. Now here we can see AM upon PN is equal to BC upon QR, so we can write it like BC square upon QR square by equation 3, right? Now, or we can write it by equation 3, area of triangle ABC upon area of triangle PQR. Since BC upon QR is also equal with AB upon PQ and AC upon PR, so we can write AB square upon PQ square equals to BC square upon QR square equals to AC square upon PR square. So this is the proof of this similar triangle theorem, right? So I am taking one question to clarify this theorem. To understanding the theorem, I am taking one question. So here I am taking one question for this. Like, question is, let triangle ABC is similar to triangle DEF and their areas be respectively 64 centimeter square and 121 centimeter square, and if EF is 15.4 centimeter, then find BC, right? So this is the question which is based on this theorem. So I am doing the solution of this theorem. Since triangle ABC is similar to triangle DEF, so by similar triangle theorem, we can write area of triangle ABC upon area of triangle DEF equals to the side corresponding to ABC is BC square and corresponding to DEF is EF square. Now we can substitute the value from here. The value of ABC is 64 and the value of DEF is 121, and the BC square we need to find, and EF square we can write 15.4 square. Now we will cross multiply this, so we will get 64 into 15.4 into 15.4 upon 121. So here we can see what we can see. We can cancel out 11 1 ja 11 times. Now this will be 11 1 ja 11, 4 11 4 ja. Now here again it will cancel out by this. Now we can write BC square equals to the square, 64 is the square of it, and this is 1.4 square. Now the square will cancel out by square. Now 14 8 ja, 8 4 ja 12, 8 1 ja 8 or 1, sorry 8 4 ja 32, 2 3, 8 1 ja 8 or 3, 11. So the answer of BC is 11.2. So this is the question based on similar triangle theorem. So this is all for today, and the remaining topic we will cover in our next video. Thank you.